Good morning, dear students, and once again, welcome back to our course. In the last lecture, we discussed in detail about the concept of maximum power transfer theorem, and I told you that according to this particular theorem, in order to transfer maximum amount of power from source side to load side, we need to apply some conditions, and the condition is, in case of DC circuit, when the value of load resistance is going to be equal to the Thevenin's equivalent resistance of the circuit, then the source will try to deliver maximum power to the load. And this is what the statement for maximum power transfer theorem. And we also derive the mathematical expression to calculate the value of power at this particular condition, and the expression for that power, or you can say P max, is going to be equal to your VTH square whole divided by 4 times of RTH. So this is the mathematical expression to calculate the maximum value of power that we can transfer from a source to load under maximum power transfer condition. That means when the value of load resistance is going to be equal to its equivalent or Thevenin's equivalent resistance of the network. And then we solved one numerical on maximum power transfer theorem, and in the last lecture I gave you one more numerical as an homework, and your objective is to solve that particular numerical. Your objective is to find the value of maximum power delivered by source to load in that particular condition. And today we will start our session first by solving that numerical, and then we will discuss the most important fundamental aspect related to the AC circuit. That means if you are dealing with AC circuit, what are the fundamental operating parameters that plays an important role? That means what is the meaning of phase, what is the meaning of amplitude, what is the meaning of frequency, then time period, what is angular frequency, how to calculate or how to represent any alternating quantity. Then we are also going to discuss the concept of average value, RMS value, followed by form factor, peak factor, and we are going to solve some numerical based on that. So before that, let us solve our previous numerical that I gave you as an homework, in which our objective is to solve what is the maximum value of power that we can deliver to a connected load in that particular circuit. So the circuit is something like this. So here we have a voltage source of value plus minus, and the magnitude is 12 volt. Then here we have a resistor of value 6 ohm. Somewhere over here we have another resistor of value 12 ohm. Then here we have one more resistor of value 3 ohm, and then a current source of magnitude 2 ampere, then one more resistor of value 2 ohm, and the circuit will close like this. Yes. And this is the terminals where we have connected a load that is nothing but RL. And in this case, our objective is to find out what is the maximum value of power that this particular circuit is going to supply to this load. So we have to calculate the value of what? Pmax. And in the last lecture, I told you that in order to calculate the value of Pmax, we have the mathematical expression as Pmax is VTH square whole divided by 4 times of RTH. So to calculate the value of this Pmax, first of all, we should know what is the value of Thevenin's equivalent resistance and what is the Thevenin's equivalent voltage. That means I can say that maximum power transfer theorem is simply the extension of your Thevenin's theorem, because in order to calculate the value of P max, first of all we have to calculate the value of VTH followed by RTH, and these two values are nothing but Thevenin's equivalent representation of a given network. So when we remove this load resistance across this terminal. Let us consider that this terminal is A and this terminal is B. So when we remove this RL, and if we see this circuit from this particular side, so whatever the effective resistance we are going to experience and whatever the effective voltage we are going to experience, they are nothing but RTH and VTH. And once we know the value of RTH, VTH, we can easily find out the maximum power that is delivered by this source, which is nothing but in the form of circuit, to this particular load, which is nothing but RL. So our objective is to calculate the value of RTH and VTH. So let us try to first calculate the value of this RTH. Now see here, in order to calculate RTH, here we need to apply deactivation rule. That means whatever the independent sources which are available in the circuit, we need to deactivate them. And I told you that if we are dealing with voltage source, we need to deactivate them by short circuit condition. And if we are dealing with current source, we need to deactivate them by open circuit condition. So if you apply that logic here, we have two sources. First one is this voltage source, and second one is this current source. So we need to deactivate voltage source by short circuiting. So here we need to remove them. In the same way, this current source we need to deactivate by open circuit. So no need to connect a current source over here. So the circuit is something like this. And at the same time, we need to short circuit this like this. Now it is going to be a short circuit condition. So here we have short circuited. We have first removed the voltage source and replace that voltage source by its internal resistance, because it is an ideal voltage source. That's why we have replaced them by 0. In the same way, here we have a current source, and because we are dealing with ideal, that's why we need to remove them by its internal resistance. And I told you that in case of ideal current source, the internal resistance is going to be infinite. That's why we need to open circuit them. Now let us try to find out what will be the value of this RTH. Now see here, this 6 ohm resistor and this 12 ohm resistors now are in parallel, and their equivalent will be in series combination with this two resistors. So I can write here as RTH is nothing but 6 in parallel with 12, and this entire combination is going to be in series with these two resistors. That means 3 in series with 2. So I can write here as 3 plus 2, which is going to be 5. I hope this is clear to everyone. That is, RTH is nothing but 6 in parallel with 12 in series with 5. So if you apply that logic, we can easily solve this. So 6 in parallel with 12 is 6 into 12 divided by 6 plus 12, that is going to be 18, and this plus 5. So 6 ones are 6, 3s are 3, 1s are 3, 4s are 5 plus 4. So the final answer for RTH is going to be equal to 9 ohm. So the equivalent Thevenin's resistance for this particular network, when we remove the load terminal and when we deactivate all the independent sources, in this particular case we have one voltage source and one current source. So we deactivated them by applying the concept of short circuit and open circuit respectively, and we have calculated the equivalent resistance across load terminal, and we got the value as 9 ohm. So this 9 ohm is going to be equal to the Thevenin's equivalent resistance of this particular circuit. Now our objective is to calculate the value of VTH. And to calculate the value of VTH, now what we need to do? Again, we need to connect the independent sources. So let me connect them once again. So here we have a voltage source, and somewhere over here we have a current source. So let me erase this. Meanwhile, you can also take pen, paper and try to solve this numerical, because the same numerical I gave you as an homework. So try to solve this. Now here we have a voltage source of polarity plus minus, and the magnitude is 12 volt, and here in between 3 and 2 ohm resistor we have a current source of magnitude 2 ampere, and our objective is to calculate the value of VTH. Now what is VTH? VTH is simply the voltage that we are going to experience when we remove this load which is connected between terminal A and B, and we are trying to find out what will be the value of voltage that we are going to experience across this terminal and across this terminal. Let us consider that this is nothing but A and this is nothing but B. So whatever the voltage which we are going to experience across these two terminals is nothing but our Thevenin's equivalent voltage. So to calculate that, because it is an open circuit condition, so whatever the current which is to be supplied by this 2 ampere current source, that has to be flow through this 3 ohm resistors and then in combination with this 12 ohm resistor. So the current is like this, which is going to be flow in this particular mesh, and the value is 2 ampere. Let us try to assume that there is another current which is going to flow in this particular mesh in clockwise direction, and the value of that current is say I. Now, to calculate this VTH from this circuit, it is very clear that this VTH is nothing but the effective voltage that is going to be appear across this 2 ampere current source, which is nothing but a, a combination of voltage that we are going to experience across this 12 ohm resistors followed by this 3 ohm resistor. So first of all, in order to calculate the value of this VTH, we have to calculate the value of this current I that is going to be flow in this particular mesh. Once we know the value of this I, then we can apply Kirchhoff's voltage law in this mesh, which is nothing but mesh 2, to find out the value of VTH. So how to solve this? Let us consider that this terminal is C, this terminal is D, this is going to be E, and this terminal is going to be F. So here we need to apply Kirchhoff's voltage law in mesh C, D, E, F, C. So starting with terminal F or node F, we are moving to C. We are going to experience a voltage rise because I'm moving in clockwise sense in the direction of current. So negative to positive, we are basically going to experience a voltage rise. So it is going to be plus 12. Then when we are moving through the 6 ohm resistors in the direction of current, we are experiencing a voltage drop. So it is going to be minus 6 into I. And then when we are moving through this 12 ohm resistors, so if you see this across this 12 ohm resistor, we have two current. First is through mesh 1 and the direction of current is I in downward, and second one is a current of magnitude 2 ampere, and both the currents are in the same direction, that means in the downward, that means they are additive, and we are trying to read the circuit in the clockwise sense. So I can write here as minus because we are reading in the same direction of current, so we definitely going to experience a voltage drop. So it is going to be minus 12 into resultant current. Now both the currents are in the same sense, so we need to add them. So it is going to be I plus 2. I hope this is clear to everyone. So 12 minus 6i minus 12i plus 2 is going to be equals to 0. Now solve this particular equation for I. So I can write here as 12 minus 6i minus 12i minus 24 is going to be equals to 0. Or I can further solve this. So I can solve this as 12 minus 24. It is going to be minus 12. Then minus 6 minus 12, it is going to be minus 18, going to be equals to 0. And then minus 12 is going to be equals to 18i, or I can write here as I is going to be equals to minus 12 by 18, or 2 6 2s and then 6 3s. So here the value of I we got as minus 2 by 3 ampere. Now see here, because the magnitude of current which we got in this equation is negative, what is the significance of this? This means that whatever the current which we have assumed in mesh 1, which is nothing but clockwise, this is not the exact direction of current. Actually, the current flow in the circuit is in anti-clockwise. So what we need to do? Now we need to assume the actual direction of current. So let me erase this. The actual direction of current in mesh 1 is counterclockwise, or you can say anti-clockwise instead of clockwise. So here the value of this resistor is 6 ohm. Here the value of this resistor is 12 ohm, and the current flow in the circuit is in anti-clockwise. This is very, very important. So the current will flow in this particular direction, which is I, and the magnitude of that I is nothing but 2 by 3 ampere. This is very important. Now our objective is to find the value of this VTH, that is nothing but the voltage which is going to be experienced across this 2 ampere current source. Now let us consider that this terminal is going to be plus and this terminal is going to be minus. Now why this is VTH? Because this is open circuit. So whatever the current supplied by this 2 ampere current source, this has to be flow through this 3 ohm resistor in this sense. So this is going to be plus, this is going to be minus. Okay, and then we have a resultant combination of this 2 by 3 followed by this 2 ampere that is going to be flow in this particular circuit. Now if you apply Kirchhoff's voltage law in mesh number 2, so how we are going to write that equation? It is very simple. Now I'm writing here, apply Kirchhoff's voltage law in mesh 2, which is that mesh. Suppose this is F, then this point is going to be G and this point is going to be H. So I am applying the Kirchhoff's voltage law in mesh 2. There is nothing but D, G, H, E, and then coming back to D, like that. Now we need to read the circuit. You may read the circuit in clockwise, you may read the circuit in anti-clockwise. Suppose I read the circuit in, say, anti-clockwise sense. So first we are going to experience a voltage rise across this 2 ampere current source, and that voltage is going to be VTH. So it is going to be plus VTH, which we need to calculate. And then when we are moving through this 3 ohm resistor, we are moving in the direction of current, and the current is 2 ampere. Hence we are going to experience a voltage drop. So it is going to be minus 2 into 3, and then the voltage across this 12 ohm resistors. Now because we are moving in anti-clockwise sense, that means in direction of 2 ampere current source, again we are going to experience a voltage drop. So it is going to be minus, what is the value of that voltage? It is going to be 12 into, now see, if you focus on this particular resistor, here we have a resistor of value 12 ohm. On one side we have a current that is in upward direction and the magnitude is 2 by 3 ampere. On the other hand, we have a current of 2 ampere that is in downward direction, and we are reading this circuit in the clockwise sense, that means in this particular sense. So what will be the resultant current? This I. So this I is going to be equal to this 2 minus 2 by 3. Why I need to take minus? Because both the currents are in opposite sense. This 2 ampere is in downward, this 2 by 3 is in upward, and we are reading the circuit in the downward sense. That's why we need to take 2 as a positive. So if you apply that logic, I can write here as 12 negative. That means we are moving in the direction of current, hence we are going to experience a voltage drop. So it is going to be minus 12, then resultant current. So it is going to be like 2 minus 2 by 3, and this we need to equate to 0. So VTH is going to be equal to, if you shift this entire term on right hand side, it is going to be 3 into 2, that is going to be 6, and then minus is going to be plus 12, then 3 to 6 minus 2, that is going to be 4 by 3. I hope this is clear to everyone. 3 to the 6 minus 2, that is 4, 4 by 3. Now 3 ones are 3 fours are 12, 4 fours are 16, then 6 plus 16, this is going to be 22 volt. This is very, very important. Now the value of VTH which we got by solving this numerical is nothing but 22 volt, and previously we got the value of RTH as 9 ohm, and our objective is to calculate the value of maximum power that is delivered from this entire network to a connected load which we have connected between terminal A and B. So to calculate that, we need to apply the concept of maximum power transfer theorem. So according to maximum power transfer theorem, the value of P max is going to be equal to VTH square divided by 4 RTH. Now what is VTH? It is 22 divided by 4 into RTH. RTH is nothing but 9. So I can write here as 22 divided by 36. If you solve this, sorry, it is not 22, it is 22 square because we have VTH square. So it is 22 square divided by 36. If you solve this equation, you will get the value of P max as around 13.4 watt. Now why watt? Because it is power. The unit of power is watt. So the answer for this particular numerical is 13.4 watt. So in this way we can solve numerical on maximum power transfer theorem. The thing is that it is simply the extension of Thevenin's theorem, because in order to calculate the value of P max which is delivered from source to load, we have to calculate the value of VTH, we have to calculate the value of RTH. The same thing we need to calculate when we are dealing with Thevenin's theorem. So maximum power transfer theorem is simply the extension of your Thevenin's theorem. The thing is that according to this theorem, the maximum power is delivered from source to load when only the value of load resistance is going to be equal to the equivalent Thevenin's resistance of that particular network. This is very important, and this is we need to deal with maximum power transfer theorem in case of a DC circuit. I hope this is clear to everyone. Once we have completed this, now we are going to start another aspect of network theorem that deals with the fundamentals of AC circuit. Fundamentals of AC network or circuit. Now what is AC? Basically, depending upon the nature of electrical quantity, we can classify electrical quantity into two main domains. First one is called as AC, second one is called as DC. AC means alternating current or alternating quantity. DC means direct quantity. Alternating quantity means what? Over a specific duration of time, on a regular interval basis, they are going to change their polarity. In some case, they are going to be positive, then next they are going to be negative, and then again positive, and then negative, and then positive, and then negative. So that type of electrical quantities are called as alternating quantity. Whereas when we are dealing with DC, they are not going to change their polarity throughout the operation. If they are positive, then they are always going to be positive. If they are negative, then they are always going to be a negative. So that is the basic difference between alternating quantity followed by direct quantity. For example, if you want to represent an alternating quantity, it is going to be like this. A pure sine wave is the best example for an alternating quantity. So in first half, the quantity is positive, and then in the next half, the quantity is negative. Whereas if you want to draw the graph for DC, it is going to be like this. Throughout the operation, it is always going to be plus. This is very important. So in case of alternating because they are going to alternate for a specific duration of time on a regular interval basis. That's why here we have the concept of frequency, because frequency indicate how many number of cycles that quantity is going to done in 1 second. But in case of DC quantity, because the quantity is not going to vary with respect to time, hence we don't have the concept of frequency. So in case of DC, the frequency is going to be what? 0 hertz. So here hertz is the unit for frequency. So in case of AC, whenever we are dealing with alternating quantity, we need to deal with frequency. And whenever we are dealing with a DC quantity, the frequency is going to be 0. This is very important. And because when we are dealing with DC quantity, the frequency is nothing but 0, or in case of DC network, the frequency is 0. Hence, all the frequency dependent, all the frequency dependent components are going to be inactive in case of DC. So they are going to be inactive. That means we have basically two different types of frequency dependent component. First one is capacitor and second one is inductor. And what is the expression for capacitive reactance? It is nothing but Xc, which is going to be equals to 1 upon 2 pi Fc. Whereas in case of inductor, we have inductive reactance XL, which is going to be equals to what? 2 pi Fl. Now, if you apply this logic, that means in case of DC, the value of frequency is going to be 0. So if you apply this logic, the value of Xc is going to be equals to infinite, and the value of XL is going to be 0. Now, in terms of open circuit and short circuit condition, this Xc is infinite. That means it is going to offer infinite value of ohmic drop to the flow of DC current, and this is, we can treat as open circuit. Infinite resistance means what? The circuit is open. That means there is no chance for a current to flow. That's why it is open circuit. Whereas in case of XL, the ohmic resistance is going to be 0. That means it is not going to offer any smallest possible value of resistance, and this is possible only when short circuit condition is applicable. Hence, this is very important and you have to remember this. That means if you connect a capacitor in a DC circuit, the opposition offered by that capacitor is infinite, and hence it is going to behave like an open circuit. Whereas if you connect an inductor in case of a DC, because the frequency is 0, XL is going to be 0, so it is going to behave like an short circuit. This is very, very important. So based on this, you may have some questions in gate, like calculate the equivalent resistance of a circuit, and the circuit is something like this. So the circuit is like this. We have a capacitor, and then here we have a resistor, and then here we have an inductor, followed by one more resistor, and here we have one more resistor. And to this particular circuit, suppose this inductor is of value say 2 farad, or this capacitor is 2 farad, and this inductor is say 1 Henry. These are very big value. Now this resistor is say 10 ohm, this resistor is again say 10 ohm, and this resistor is say 2 ohm. And to this particular circuit, suppose we have connected a DC voltage source of polarity plus minus like this. Let me redraw the circuit. So here we have connected a voltage source of polarity plus minus like this, and the magnitude is say 14 volt, and our objective is to find out the value of current supplied by this DC voltage source in this particular circuit. So first of all, we need to apply that logic which we just discussed, that in case of DC, the uh, Xc is going to be infinite, that means open circuit, and XL is going to be 0, that means short circuit. So whenever we are dealing with a DC network, and in that if we have a frequency dependent component like inductor, capacitor, so wherever we have capacitor we need to open circuit them, and wherever we have inductor we need to short circuit them. So in case of inductor we need to short circuit them, and when we are dealing with capacitor we need to open circuit them. So if you apply that logic here, because this is capacitor, it is going to behave like an open circuit, so no need to connect a capacitor, this is going to be open circuit. In the same way here, this is nothing but inductor, so it is going to behave like a short circuit, so no need to connect inductor over here. So the circuit is something like this. So this is going to be open circuit, and this is going to be short circuit, so we need to connect them. So this is going to be a short circuit condition. Now let us try to find out what will be the equivalent resistance of this entire network. Now see here, this is open, so no need to consider this path. Now here we have this 10 which is connected in parallel with 10, and the effective value is connected in series with this 2 ohm resistor. So in order to calculate the value of I, first of all we are going to calculate the value of R equivalent of this network. So R equivalent is going to be like 10 in parallel with 10, and this is going to be in series with this 2 ohm resistor. So 10 in parallel with 10, I can write here as 10 into 10, which is going to be 100, divided by 10 plus 10, which is going to be equals to 20. So this is going to be 5 plus 2. So this is going to be what? 7 ohm. So 2 ones are 2 5s are 5 plus 2. This is going to be 7. So the effective resistance of the path is 7 ohm. Now once you know the value of R equivalent, we can easily find out the value of current. So current supplied by this source is going to be equals to V divided by R equivalent. So what is V? V is 14. What is R equivalent? That is 7. So the answer for this is 2 ampere. This is very, very important. I hope this is clear to everyone. And this is what the beauty of connecting a DC source when we have dependent frequency component in the network. The thing is that we need to identify that whether we have a capacitor or inductor. If you have a capacitor, just open circuit them. If you have an inductor, just short circuit them. And this is for steady state condition observation. So this we solve for steady state condition. This is very, very important. In the same way, suppose if I interchange the position of inductor and capacitor in the same network. For example, instead of having a capacitor over here, now suppose if we have an inductor over here, and instead of having inductor over here, suppose we have a capacitor, then what will be the value of I? Let us try to find out that. So see here, suppose instead of having capacitor, if we have inductor, so this is going to be short, and instead of having inductor, suppose if we have a capacitor, so this is going to be open circuit. So this is going to be short, and this is going to be open circuit. Now let us try to find out the value of I. Now because this path is disconnected completely with respect to this particular network, so this network or this portion of network is not going to have any influence on the magnitude of this particular current. That means to find out the value of current, now we have only this portion of the network in picture. And in this network, we have only a series combination of 10 ohm with 2 ohm resistor. So with respect to this particular condition, if I try to calculate the value of I, so it is going to be equals to what? V by R equivalent. So V is 14 divided by R equivalent. So R equivalent is going to be this 10 ohm resistor in series with this 2. So it is going to be 10 plus 2. So I can write here as 14 divided by 10 plus 2, that is going to be 12. So this is going to be like 7 by 6 ampere. This is very important. So this is what the effect of changing positions of frequency dependent component in the network if we are dealing with a DC source. So previously we have not alter the network, the value of current supplied by the same 14-volt source is 2 ampere. Now, what we have done, we simply change the position of frequency dependent component. Instead of connecting capacitor, we have connected inductor, and the inductor is replaced by capacitor. The value of current is automatically get changed. Why it is going to be changed? Because we need to apply this philosophy. Wherever we have capacitor, we need to open circuit them. Wherever we have inductor, we need to short circuit them. And based on that, the equivalent resistance of the circuit is going to be changed. And if equivalent resistance is changed, automatically the value of current supplied by the source is also going to be changed. This is very important. I hope this is clear to everyone. So this is what the fundamental aspect of what exactly AC and what exactly DC is, and how the frequency dependent components are going to behave in case of a DC network. Now, as far as AC quantities are concerned, the graphical representation for AC quantity is like this. On x-axis, we need to indicate time, or we may take angle, which is in the form of theta. And the best wave shape for an alternating quantity is nothing but a pure sine wave. So it is going to be like this, perfect sine wave. And let us consider that the alternating quantity here I am taking is nothing but say I. So small I indicate the instantaneous value of this alternating quantity. And mathematically, I can represent this I as I max into sine of omega t plus theta. Now, instead of taking theta, now I'm writing this in terms of omega t, where omega t itself indicate the variable components in our case. Let this will be your equation number 1. Now, what is the meaning of this? Let us try to identify what are the terms available in this mathematical equation. Now, the first important term is this I. This I is known as instantaneous value. Instantaneous value of alternating quantity. Now, in this case, because I have taken the alternating quantity as current, that's why I have indicated that value as small I. Now, suppose if you want to calculate what is the value of this I at this instant, say 0, or if you're interested to calculate what is the value of this I at this instant, say 90 degree, or at 180 degree, or at 270 degree, or at 360 degree. So whatever the value at that particular instant defines the instantaneous value of that alternating quantity. For example, at omega t equals to 0, the value of this alternating quantity is 0. That's why the instantaneous value of this I at omega t equals to 0 is going to be equals to what? 0. In the same way, if you are interested to calculate the value of this I at omega t, say 90, then in that case, from this graph, it is going to be easily visible that it is the highest possible value, that too in positive sense. So this particular value is indicated by symbol I max. And what is this I max? This I max indicate the peak value. So at omega t equals to 90, the value of, or the instantaneous value of this alternating current is going to be equals to what? I max. And this I max indicate its highest possible value, or sometimes this is also known as the amplitude of this alternating quantity, which is very important. In the same way, suppose we need to indicate what is the frequency of this alternating quantity, how to define that. So let me indicate first, this indicate the amplitude. This is your I max. Then this omega, what is the meaning of this omega? Omega is known as angular frequency. It is angular frequency. angle of frequency. And the expression for this omega is like 2 pi f, and the unit for this angular frequency is radian per second. This is very, very important. Now see here, the unit of omega is radian per second, and if you multiply this by t, where t is time, which is in second, so let us try to find out what will be the unit for this omega t. So omega is radian per second multiplied by time, which is in second. So this second will get cancelled. You will get omega t unit is radian. That means it is nothing but angle. You may specify this in terms of radian, or you may specify this in terms of degree. That's why this omega t itself indicate angle, and hence we have indicated them like 0, 90 degree, 180 degree, 270, 360, or you may take this as 0, pi by 2, pi, 3 pi by 2, and then 2 pi. They are nothing but the same thing. So omega is angular frequency, and the expression to calculate this is 2 pi f, and the unit is radian per second. Now if you see the mathematical expression for omega, which is nothing but 2 pi f, so here this f is called as frequency of this alternating quantity. Now what is frequency? Frequency is nothing but the number of cycles done by this alternating quantity per second, or in 1 second how many number of cycles are covered by that alternating quantity, or how many number of cycles were done by that alternating quantity in 1 second. That indicate its frequency. And as far as Indian scenario is concerned, for an alternating circuit, whenever we are dealing with AC quantity, by default their frequencies are going to be 50 hertz. What is the meaning of this? 50 hertz means what? That alternating quantity is going to complete 50 number of cycles in 1 second. So cycle per second or hertz, they are nothing but the same thing. So hertz is the standard unit for frequency. And in India, whenever we are dealing with alternating quantity, by default the value of AC quantity frequency is going to be always 50 hertz. That means that quantity is going to complete 50 number of cycles in 1 second. This is very important. In the same way, let us try to define the concept of time period. What is time period? Now time period is simply the inverse of frequency. It is indicated by symbol T, capital T, and it is going to be equals to 1 by f. So if you deal with this particular topology, I can write here as 1 by 50. So it is going to be 20 millisecond. So time period for an alternating quantity, as far as Indian scenario is concerned, is always going to be 20 millisecond. This is very important. Now what is the meaning of this? The meaning is very simple. That means if you have an alternating quantity and suppose if you take t on x-axis and any alternating quantity on the y-axis, and if you represent the graph like this, something like a sine curve, I told you that the time period for an alternating quantity is this much. That means the time taken by that quantity to complete 1 cycle. So this is going to be your time period. And as far as we are dealing with alternating quantity with respect to Indian scenario, we have a constant frequency, which is nothing but 50 hertz. So if you take inverse of this, you will get time period as 20 millisecond. So the value for this capital T is going to be 20 millisecond. And if you divide that into two sections, so time period for 1/2 cycle is going to be equals to the 10 millisecond. This is very, very important. That means after every 10 millisecond, that quantity is going to change its nature. First 10 millisecond, if it is positive, the next 10 millisecond, this is going to be negative. And then in the next 10 millisecond, this is again going to be what? Positive, and then negative, positive. So this periodic behavior keeps on repeating. That's why these quantities are called as alternating quantity, because they are going to change their magnitude over a specific duration of time continuously. In India, because the frequency is 50 hertz, that's why the time period is 20 millisecond. And if you divide it by 2, you will get the time period for one half cycle. It is 10 millisecond. So for first 10 millisecond, if the quantity is positive, then in the next 10 millisecond, it is going to be negative, and then positive, and then negative. So this is what the concept of instantaneous value. Instantaneous value means what? It is nothing but the value of that quantity at that instant. That's why it's called as instantaneous value. Then we discuss the concept of amplitude, highest possible value of that alternating quantity in one cycle. That is nothing but this amplitude, which our is this. So this indicate your Imax. This indicate your Imax. This is negative Imax and this is positive Imax. Then we discuss the concept of angular frequency. The unit is radian per second, and the expression for omega is 2 pi f. Or you can write this equation as 2 pi by t, because f is 1 by t. So you can calculate the value of omega by using this formula, or you can calculate the value of omega by using this particular formula. And then we discuss the concept of frequency, which is nothing but cycle per second. And then we discuss the concept of time period, which is nothing but inverse of frequency. That means what is the duration uh, taken by that quantity to complete one cycle. That is nothing but time period. And in Indian scenario, the frequency is fixed. That is nothing but 50 hertz. That's why time period is also going to be fixed, which is 1 by 50. The answer is 20 millisecond. This is very important. And then one more term is remaining over here, and that is the concept of this theta. This theta is nothing but phase angle, which plays very important role in order to define at what instant this alternating quantity is going to appear in the circuit. In some cases, if you take theta as 0, that means the moment you switch on the supply, uh, with respect to reference, it is not going to take any time delay. In the sense, if you have theta in picture, it may be say plus 10, it may be say minus 10, or it may be say any value. There will be a delay with respect to, or there will be advancement with respect to your reference value. So what exactly this, whether it is lagging or leading, that we are going to learn in detail in the coming sessions. But for time being, let us consider that this theta is nothing but your phase angle, and basically it is going to define the instant of this alternating quantity with respect to the reference value. Now, because in this case we don't have any another alternating quantity, that's why it is very difficult to identify that theta. But suppose if you have more than one alternating quantity, and suppose if you want to define the reference, the instant of time with respect to each other, then in that case this theta plays an important role. So basically ये theta हमें बताएगा कि अगर आपके पास में दो या फिर दो से ज्यादा अल्टरनेटिंग क्वांटिटी है और आपको बताना है कि इनमें से कौन सा क्वांटिटी पहले आया, कौन सा क्वांटिटी बाद में आया, then in that case this is going to play a very important role. For example, if the theta is 0, the quantity will start from this particular point itself. For example, if the theta is say plus, that means it is going to lead. Lead means it is going to start before this value. So it may start like this. So this is nothing but your theta. In the same way, if the theta is negative, negative means lag. Lag means बाद में आना, delay होना. Delay होना means what? If the theta is not in the picture, the quantity has to start from this particular point. Now, because here theta is negative, that's why it is going to start its journey by some time. So here we can start this like this. So it is going to be the lagging, which is nothing but minus theta. This is going to be plus theta, which indicate leading. So in this way, we can define the instant of this quantity with respect to our reference value. So this theta plays very important role at what instant that quantity is going to be appear in that particular network with respect to the reference value. So this is what the phase angle is, and we can define that phase angle either in terms of radian or in terms of degree. So I hope this is very clear to everyone. And there is one more concept which I supposed to explain you in this session, and the relationship between this theta and time. What is the relation that I will explain you? Suppose if we have two alternating quantity, let us consider that on y-axis I have indicated current, on the x-axis I have indicated theta, which is in degree, and the first alternating quantity is like this, and the second alternating quantity is like this. Suppose this is say I2 and this is say I1, and they are going to have a phase difference with respect to each other in the form of say theta 1. And suppose if you are interested to find out what is the relation of this theta with respect to time t. So from this equation it is very clear that uh, at theta equals to 0 we have only one quantity, and the quantity is I1. So I1 comes first in picture, and then after an angle delay of theta, or you can say theta 1, we have another quantity, and the quantity is I2. And suppose we want to find out the relation of this theta 1 in terms of time, that means I1 के कितने देर बाद आपका I2 पिक्चर में आया in terms of time, that means in terms of second. अगर आपको find out करना है तो आप कैसे करेंगे? That means what is the relationship between this theta with respect to time? That is our objective. So how to find out that? Now remember one thing, whenever we are dealing with alternating quantity with respect to Indian scenario, the frequency is going to be changed. Frequency is going to be your 50 hertz. It is not going to change. So for both the quantity, whether it is I1 or you can say I2, both are going to change at a constant frequency of 50 hertz. This is very important. That means the time period for both the quantity are nothing but same. Now, if you consider the time period for first, it is this much, and the value is capital T, which is going to be 1 by F, 1 by 50. So this is going to be what? 20 millisecond. And if you consider one complete cycle, so in terms of angle, one complete cycle means if this is 0, this is going to be 180, and this is going to be your 360 degree. So I can write here as one complete cycle, one complete cycle is going to be equals to what? One time period. One complete cycle in terms of angle is going to be what? 360 degree, and one time period is going to be 20 millisecond. This is very important. In the same way, suppose we want to find out 180 degree means how much time duration. So it is going to be exactly equals to what? 10 millisecond. In the same way, if you are interested to calculate 90 degree corresponding to how many time duration, it is going to be what? 5 millisecond. In the same way, if you are interested to calculate 45 degree corresponding to how much, so it is going to be 2.5 millisecond. So this is very important. So basically I have applied a logic that one complete cycle in degree is going to be equal to one time period of that alternating quantity. So this is what the basic logic, or this is the conversion factor or the conversion formula between degree into time. So in this case, see here, with respect to reference value I1, or with respect to this first alternating quantity I1, the second alternating quantity will start at theta 1, which is nothing but at this particular instant. Now, this instant is going to be what? 90 degree. That means with respect to I1, quantity I2 will start after 90 degree. And according to our conversion factor, 90 degree corresponds to 5 millisecond. That means at time t equals to 0 second, for example, we have alternating quantity I1, then after time of 5 millisecond, Why 5 millisecond? Because 5 millisecond corresponds to 90 degree. And from this graph, it is very clear that after 90 degree of delay, quantity I2 comes into picture. So after 5 millisecond, I2 comes into picture. This is very, very important. And because it is lagging, that's why we need to take this as minus. So here it is going to be lag. Lag means it will come after the reference value. So if you want to define this in terms of mathematical equation, so how it is going to be? It is like this. Suppose if you define this I1 as I max 1 into sine of omega t, you can take this as theta or omega t. Then with respect to this, I2 is going to be equals to I max 2, because from this graph it is very clear that this is your I max 1 and this is going to be your I max 2. So I max 2 into sine of omega t, because both are varying at the same frequency, which is nothing but 50 hertz. Hence the value of omega is also going to be same, which is 2 pi f for both the quantity. And then here we need to define whether it is lagging or leading. So with respect to current I1, current I2 is going to lag. That's why we need to take here as minus. And for by what angle it is going to lag? It is going to lag by 90 degree. So here we need to take minus of 90 degree. So this is what the beauty of phase angle. So with respect to current I1, if you take I1 as a reference, because here we have taken reference, that's why we have not defined any phase shift. So with respect to current I1, I can define this I2 as a lagging quantity. So this is what the mathematical expression for these two alternating current. It may possible that we may take current I2 as a reference. Then in that case, I1 is going to lead. So how to write the mathematical expression for those quantity? Now see here. Suppose if you take I2 as a reference, so I can write I2 as I max 2 into sine of omega t. Now here I have taken I2 as a reference quantity. So with respect to this, I1 is going to appear 90 degree ahead or 90 degree before the reference quantity. So I can write here as I1 is going to be equals to I max 1 into sine of omega t plus 90 degree. This is very important. Now plus means ahead. It is nothing but leading. That means with respect to I2, with respect to I2, I1 is going to appear 90 degree before the value. So whenever we are dealing with leading quantity, we need to take angle, phase angle as positive. Whenever we are dealing with lagging quantity, we need to take phase angle as negative. Lagging means after the reference value. That means we need to shift in the rightward direction. Leading means before the reference value. That means we need to shift in the leftward direction. So this is for leading and this is for lagging. For leading, we need to take plus. For lagging, we need to take minus. So this is very important. And if you understand this, then it is very easy for you to solve fundamental questions based on AC circuit. So that we are going to take in the next class. Thank you.